My name is David Costa, and it is my honor to do this. I would therefore call upon the first speaker, Javier, who is going to talk about running coupled simulations on HPC and cloud resources with enhanced TOSCA workflows. Please go ahead.
Can you see my screen?
We can see your screen.
Okay, so well, I'm Francisco Javier Nieto. I'm from Atos, and I'm the coordinator of the Hidalgo project. Already some people from this project has been presenting things, so you pretty much know the kind of things that we do. And what I wanted to show you is the I wanted to talk about how we orchestrate the applications, that the simulations that we have in the project, and how we could use the orchestrator we have in order to manage the coupled simulations. Okay, so all in all, this is a presentation which has to do more with how to manage the resources when you are going to run these kind of simulations. So basically, the key element here is what we call the croupier. Croupier is an orchestrator based on Cloudify, which basically provides the capability to run jobs in HPC. Cloudify is an orchestrator for cloud environments only. It has a lot of connectors, and it's very nice for that, but it does not have the capability to connect to HPC systems. And therefore, what we did is develop this kind of extension. So now we are able to send jobs to systems which are managed by workload managers like Slurm and Torque. Okay, and we also are including capabilities to use HPDA systems based on Apache Mesos. Another thing that we have been including with the time is some support for the data movement. So for example, we have included some functionality that allows you to easily move data with FTP. Also to publish data sets in sican. Sican is a data catalog, so you generate some result with your simulation, and then you just tell the orchestrator to publish your work in this data catalog, and the data will be published there. Okay. And one of the good things that this orchestrator has is that it allows us to combine HPC and cloud resources for running these simulations. Okay. The good thing is that sometimes you can decide to optimize in the time that you're going to use, or the core hours efficiency, these kind of things. So it has some benefits, and it also includes the possibility of some built-in monitoring. So basically, we are able to take metrics from Slurm and Torque, but this is, let's say, optional, because you may have your own monitoring solution, okay, for collecting the data. So it's usual that, for example, we deploy this orchestrator together with a Prometheus monitoring solution. And the way in which you define the workflows in Croupier, in Cloudify in general, is TOSCA. TOSCA is an OASIS standard for defining workflows for cloud applications. Because of these things that we have been doing, because what we did in the end was to propose some extensions in line with the TOSCA DCL still, so it's, let's say, complying with the standard. What we have seen is that the OASIS community and the TOSCA working group is really trying to include more things. So their idea is that it won't be only cloud, but also it will support more technologies. The good thing is that okay, it's based on YAML. It's not so complex to understand. Once you see it and you have some familiarity with it, it's quite readable for anybody. And also there are graphical editors that can allow you to, or facilitate the way in which you design the workflows. Alim4Cloud is an example. Okay. So about the architecture of the orchestrator itself, well, basically you have on one side some interfaces that can be used for accessing the functionality, you can do it through command interfaces or through REST APIs. There is some part which is dealing with the TOSCA files and the input files. And the center of everything is the workflow engine that basically takes care of running each task of the workflow and sending, asking this infrastructure engine to send the tasks to cloud or to HPC, depending on how you configure that. So as you see, the possibilities that this infrastructure engine is the one which takes care of the connection with the different systems. And in our case, it's possible to ask directly the workload managers to take some jobs, or it's possible to create VMs in a cloud infrastructure and send the tasks that you need to run. As I said, it has the possibility to retrieve some monitoring information, but it's usual that we have some other monitoring infrastructure in which you are collecting information with some exporters and later on to access the information from there, okay? Because usually they have their own interfaces. The good thing is that they are, I mean, in our case, we are not dealing with monitoring information in an efficient way. These kind of solutions have databases prepared for time series data, and they are much more efficient. So usually it's much better if you have that kind of solution. So how the simulation workflows. So a workflow is in the Cloudify language is a blueprint. Okay, as I said, it's a YAML file. And as I said, what we did is to define some extensions to TOSCA. I put here some examples. So there is a type which is group year nodes job, which is for defining that what you have there is a task that will be devoted to HPC. Also, there are different relationships that we have defined. These ones are pretty much in line with the standard ones in TOSCA, but just a bit adapted to the HPC part. And also we had to define the way in which you would define the characteristics of the HPC system that you are going to use, and some information which is necessary, such as, for example, where's the endpoint, your credentials, things like this. Okay. The good thing is that instead of running the jobs by yourself, once you have a blueprint like this, it's possible just to reuse it all the time, and it's not very complicated to write it. And as I said, one of the positive points for the coupled simulations is the possibility to define relationships. So I just wanted to show a small example of how you define relationships, which is here in the right side. So you have, for example, just 4 tasks in your workflow. You see that there are some relationship with respect to which task should happen before, right? So in that case, you just define that a job is depending on another job. Okay. You see that, I mean, the way to define is not very complicated. You say in the relationships that you have a certain type of relationship, which in this case would be job depends on, and it depends on the target, which is first job. So I mean, it's not very complicated in that sense. So what's the idea behind these couple simulations with group here, and what needs to be done? So as I said, the main objective is to be able to optimize the performance in the resource allocation, especially when we are running the applications. I mean, what we want to do is when you have 2 simulations which are closely interlinked, they're sharing data because of this coupling that you have. You need to be careful because depending on the data that they need to share and the way that they need to synchronize, if you are not running them all together, for example, you may have an issue because of the performance. But on the other hand, if the kind of coupling is rather weak and you want or you need to separate the execution, having part of it in the cloud, part of it in the HPC, or in 2 different HPC centers, because maybe you are trying to run something which is very big and you have only access to some HPC centers which have so many resources, right? And it may happen that you need to run things in two different centers. So we want to provide some solution that could allow to do this thing. So one way to do it is to use this relationship part and this relation that we can define right now, which is the job depends on. The problem is that it only is useful. It's only useful when you are defining some acyclic coupling, in the sense that it's clear that you have a task which is going to happen before the other one, and they need to share the data. And actually, even if they are running in parallel somehow, you may need to know which kind of data they need to share. The problem is that if, for example, in the example we had before, we have two tasks running in parallel, and you want to model that that coupling between them. Right now, there is no way to do it, which would be the orange arrow that you can see there. Okay.
Javier, 5 more minutes.
Okay. Yeah, it's only 2 slides more. So what we propose is to define two new kind of relationships. First of all, one for strong coupling. This is when you have two simulations that are coupled through message passing interfaces, because you are using MPI, or well, it could be also GASP, things like this. Or there is some communication set up with sockets. So basically, they are interchanging messages all the time. And the other one is the quick coupling, in the sense that they are sharing data, but maybe in files, or that one of them has to access some REST interface for downloading some data, things like this. I mean, which is not so intensive in terms of the data that you are all the time sharing. And the idea will be just to define these two different types. One could be job MPI coupled with, and you will define in the target part which is a task you are related with, and job data coupled with, which will be working in the same way. So the question would be, okay, so what does it mean for in terms of how to allocate the resources, how things should work? So the point would be that in those cases in which we think that we have a strong coupling mechanism, the first option would be always to allocate the both tasks in the same HPC center, no matter if they are acyclic or cyclic, because you know that they are going to be exchanging a lot of information, and especially with MPI, that we are supposed to have a very good network infrastructure based on InfiniBand and things like this. That otherwise you are losing out of performance. Right? In the case of weak couple mechanism, we could differentiate between acyclic and cyclic, in the sense that in cyclic ones, we expect both of the tasks or simulations to be interchanging a lot of information pretty much all the time. So the traffic could be high. And in that case, the preferred option would be to put them in the same location, but still, depending on the data flow they have and the kind of mechanisms that we have available, it could be possible also to allocate them in different locations. And for the cyclic case, it could be possible to enable this part of allocating one in HPC, another one in cloud, or even if we see that the data to move is too much, then we can force to have them in the same location. Because in the end, this combination of HPC and cloud, or HPC plus another HPC center, is only valid if the amount of data that you need to manage is not too high. Okay, you need to see that there is a trade-off, because the time you lose moving the data will eat this time that you gain when you are running in parallel. And this has also some effect in the monitoring side. That's just this last point, that we will need to monitor the network load in order to see if the decision that we have made is good, in terms of the kind of coupling mechanism, and in terms of the allocation of resources, and also the data movement, just to see how much data we are moving in the end, how these are working. Okay, and that's
one more
all.
minute. Never mind.
Thank you very much for that very interesting presentation. Are there questions? I remind people to type them into the Q&A panel, and then I will read them out to the speaker. There are no questions yet. I will have one of my own.
Okay.
How much of what you presented is actually in use?
Yes. We have the orchestrator running, in Hidalgo it's running, and also in other projects. What we have to do now is to implement these extensions that I was mentioning, more focused on the coupling mechanism part, which is something that until now we were not doing.
Thank you. I'm still waiting for any questions.
Yeah, I don't know if somebody posted something in the chat.
We might actually, so Lorenz, did you want to ask a question? You see, the panelists aren't able to type in into the Q&A themselves, but.
Right, yes, I just have a question, if you can hear me.
Yes, go ahead, please.
Right, I was wondering about the difference between this job data coupled with in an acyclic relationship and a normal TOSCA dependency, because it seems to be that in both cases one step would run first and then the second step runs and there's information passing from one to the other, or am I misunderstanding this?
Mm-hmm. Yeah, in principle, this is the way in which it's working, but it's also true that yeah, I would say that that's the way to go right now. Yes, the point is that we can do some interpretation of it, because even if you define, because as you can see that the kind of relationship which are defined that we are using right now are not exactly the ones that are defined by TOSCA. Okay, so at some point it's up to us to define if we would like to do some interpretation in which you don't need to really wait until the end of the previous task. So you can use it like a dependency, saying that there is this relationship, but it doesn't mean that it has to be finished before the other one starts. I mean, it's up to the way in which we implement internally in the orchestrator, because we have the possibility to change that. So in that case, we could allow the, I mean, we can enable that acyclic mechanism just with the normal relationship. This one depends on.
Okay, that's clear. Thank you.
I see no questions from the general audience. So thank you very much. It was a very interesting talk.
Thank you.